Hi Sec 3s, today I'll be going through Kpt worksheet 2. I shall not go through the first 3 MCQ questions also, because I think they're relatively simple. So let us look at the tougher MCQ questions. Okay, so here right, we are given a cooling curve of a substance, and they tell us to correctly identify P, Q, and R. So right here right, if you can see for Q here, Q is where there's a transition in state. So right, likely right, there can only be 2 options for Q. So Q right can either be what we call condensation or freezing, because it's a cooling curve. Okay, so can only be these 2 processes. Okay, so for condensation right, so similarly now you just link back condensation. What 2 states of matter do we involve for condensation? So I think this one we can link to liquid and gas. Then for freezing right, we link to solid and liquid. Okay, so now so let's look at the options available. So okay, so for P and R right, it's either here, this one should be gas or liquid. Then from here should be liquid or solid. Okay, so here right, B and D we can just strike out already, because it involves gas and gas, confirm wrong. So let's look at A and C. Then similarly right, like we say condensation or freezing, so it can only be gas to liquid or liquid to solid. So C also should be out because it's gas to solid. Okay, so answer should be just A. Okay, okay, let's move to question 5. So question 5 is a very classic melting point and boiling point question. Then right, they will ask you to either state the state of the metal at a certain temperature, or you identify at which temperature right is a specified state. So like, let's say at which temperature is a solid, which temperature is a liquid or gas. So here from -7 to 63 right, so anywhere above 63, so what this implies right, boiling point of 63 degrees, more than 63 degrees right, must be gas. Then under -7 degrees Celsius must be solid. So right, any temperature right between -7 to 63 right will be existing as a liquid. So if we see here C 75, this one confirm out already. This one confirm is a gas. D also don't need to say lah. Anything onwards here is all gas already. So this one we just cross out. -25. -25 right is a more negative than -7. So this part right is a solid. So -25 is a solid. So A also out. Answer must be B. Okay. Okay, now question 6. So similar thing, liquid at 20 degree. So what it means right, 20 degrees Celsius right should be existing in the middle of the MP and BP. 20 degrees Celsius. So you just check lor. -22 to -3. So this one is already existing here already. So this one is wrong. -8 and -33 degrees. This one also not possible. In fact, this one right, it should be the reverse. This portion should be reverse. The lower temperature should be the MP. The higher temperature right, -8 should be the BP. This one also sure wrong. A and B is wrong. Then let us look at D. So bromine 20 degree right, 20 degree is here. Is lower than the MP. Lower than MP means solid. Okay, so if it's a liquid right, answer only can be C, because C is in between. 20 is in between -7 and 59. Okay, answer is C for question 6. Okay, then question 7, room temperature. So take note when we see room temperature right, it refers to this temperature, 25 degrees Celsius. So just see so if arrange randomly. So here, so second thing you take note, arrange randomly. this implies that the substance is a gas. Okay, so gas, right, means it should exist, right, minimally, right, at the BP or even higher. So it should exist, right, at this portion here. Okay, so this part is where it exists as a gas. So let's look at B and question B. So room temperature, right, melting point is 120. So actually it exists 25 degrees Celsius is here. So this one also wrong already. It means that 25 degrees at this range of values of MP and BP, the the substance exists as a solid. Then look at question C. C also similar. It exists here. Sorry. Exists here. Exists here means also solid. So here I will just write solid. Then for D also, yeah, also solid. So the only possible answer, right, is left with A, because A, right, is actually existing here. Yeah, above the BP. Above BP, right, you are always a gas. Okay. Okay, if not, right, I think we are done with the MCQ questions. So let's move on to the structured questions. So here, right, I've used my highlighter to actually denote 5 parts of the heating curve over here. Yellow, green, blue, pink, and orange. So in this case, right, we can maybe just label them accordingly. So this part must be solid. Then this is melting. Sorry, the state change, right, I'll just write in blue. So here melting. Then this part here is a liquid. Then this part here is boiling. Then lastly, right, we'll have a gas here. Okay. So at A, right, yeah, it's just melting because it's changing from solid to liquid. So A part 1 I shall not go through in detail. Then now A part 2. So the question asking you why temperature rose before A. Then after that, right, remain constant, even though it was heated. So first part, right, you just state that for A, before A, right, before we actually reach the melting point of the substance, right, you can just say that thermal energy is converted to KE. Then KE, right, will increase KE will lead to an increase in temperature. Okay, so this is the first part. Then second part, right, why the temperature remain constant? So always link back to your during a change in state, there is no gain in KE because the energy is used to overcome forces of attraction. Then no gain in KE equal no change in temperature. Okay, so just always link back to this whole concept. Okay, part B, process that occur at B takes a longer time. Okay, so yeah, it's true because as we can see here, right, B, this time here, sorry, yeah, can we see that the pink color highlighted portion is way longer? This part here is way longer than this green portion here. Yeah, and there's a reason why. If you learn physics, you'll know why. This process is actually this concept called latent heat. Latent heat of vaporization and latent heat of fusion. So the latent heat of vaporization is always higher than latent heat of fusion, because in reality, right, to change a liquid to a gas, right, you require much more energy to allow the particles to become very far apart and to move in a disorderly manner. So that state change, right, will require a lot more energy. Yeah. So just link back to the concept of energy lah. You need more time, right, because more heat is required. More heat is required means more thermal energy. Yeah, more thermal energy means you require more energy to overcome the forces of attraction. Okay. Okay, so for part 9, I shall not go through in detail the whole part A. You should be able to identify these 4 processes from the heating and cooling curves easily. Just look at part B and C, and also part B and C of this question. So now, right, they ask you to use Kpt and energy change. So here, first part use Kpt, and then energy change. So heated from, so these two temperature 110 to negative 90. So let's see what happened from 110 to minus negative 90. Wait first. Okay, so 110 to negative 90. Let me see. Okay, so okay, negative 110. If not, I was like wondering, how come from 110, right, a larger temperature you heat, then it became lower temperature. Okay, from negative 110 to negative 90. So from a more negative value to a less negative value. Okay, so let us see what happens here. So negative 110, right, is this portion here. Then negative 90 is when this portion basically the process where methanol goes through melting. Okay, so here so let's just write out the states. So here you must be existing as a liquid. Then here you go through melting. Okay. So yeah, so describe the arrangement of particles in a solid first. At negative 110, which is closely packed in an orderly manner. Okay, so in this case during melting, right, yeah, because at melting you will exist as a mixture of liquid and solid. So yeah, at the solid liquid portion, right, you will become closely packed in a disorderly manner. So first thing, right, state the change in the arrangement. Second thing, state the change in the particle movement. Okay. Okay, so then after that, right, the last portion is to always state the during the melting process, right, why temperature did not change. Okay. Okay. Then from selenium between E to F, so I'm referring to this curve here, E to F. Okay, so here E to F, as we can see here, this is a change in state. So this should be what we call condensation, right? Yeah. So condensation is when a gas turns into a liquid. So state what happens. So energy change, right? Always link back to whether there's a gain or loss in thermal energy. Yeah. Then because of this gain or loss, right? Link back to the what will happen to the spacing and then the forces of attraction between the particles. Okay.